Hey guys, welcome to the video. In today's lesson, we're going to talk about microservices and integrating Docker Compose in them. So I have prepared a fully working .NET application which has 6 microservices, and here is the diagram to help us understand the application better. So first things first, we have 3 API servers: identity service, dealer service, and statistics service. These provide data for corresponding data models and entities. The whole application is about car dealers, which can publish different car ads for renting. So pretty much we have a user which can register here through the user client. The user data is stored in the identity service, which has its own private identity database, which is the correct way to implement microservices. Each microservice should have its own private database. Then we have, when the user registers in the identity service, he then becomes a dealer, which is stored here in the dealer service. From here on, the user can easily publish different car ads in the system, and other users, without registering, can search through the car ads. That's the idea. That's the whole idea. And finally, we store various statistics in the statistics service here. For example, how many car ads are in the system, how many views each car ad received, and so on. These communicate with each other through a message bus. In my implementation, that's a RabbitMQ instance. And we have an admin client, which is a separate microservice. The admin client is responsible for providing administration access. It can access all these services and edit their data. We also have a notification service which on each car ad, on each created new car ad, sends notifications to all the clients which are currently connected to the server. Pretty much these are the different microservices, and we have a separate one which is called a watchdog. The watchdog just calls each of these microservices and checks whether they are healthy or not. That's the whole idea of the watchdog. Good. So this is the main diagram, and here is the implementation here. I'm not going to cover deeply how to implement microservices with .NET because that's not our focus today. But if you're curious, I strongly suggest to take a look at the code here, because these microservices follow the best practices, and I believe they can serve as a good example for you if you decide to create a microservice application on your own. Good. So we have all the services here, and let me show you what else we need, because we need also SQL Server, and since I have SQL Server installed on my machine, it's completely okay to not run it in Docker. And I have a RabbitMQ which should be run in Docker because I haven't installed it on my machine. So in this file here, which I'm going to link next to the lesson, in this file here, third-party containers, we have two Docker commands which apparently create SQL Server instances for you and RabbitMQ instances. So you can use this if you don't have locally installed SQL Server or RabbitMQ. And since I have SQL Server already, I'm just going to run the RabbitMQ command in a minute. I just wanted to say that I'm not going to cover basic Docker commands. I'm just going to cover the practical aspect of making these microservices working with Docker Compose. So if you want me to create a Docker specific course or lesson, let me know and I'm going to do one. So I assume that you already know basic Docker commands and basic Docker terminology, like, for example, mm, images, containers, how to run them, how to delete them, what are volumes, and so on. Cool. So let me open a terminal first. I would like to run and start a RabbitMQ instance because I would like to have an event bus up and running so that if I run the microservices, they will be able to connect to the RabbitMQ instance. So let's open Docker dashboard. I can see that I have the RabbitMQ management container up and running for 23 seconds. I'm not sure why they are not shown here, but nevertheless it doesn't matter. Good, so let's run the microservices just to make sure that everything is working correctly. I have the admin, dealers, identity notification, statistics, and watchdog. All of them are set to start. So let's run all the consoles and see that it's not very convenient to run and debug the services. It's not the best way possible, but still. Good. I forgot to mention that we have an Angular client here, which I'm going to run later through Docker Compose directly, but the Angular client allows me to create a user, register as a dealer, create a carrot, search the carrots, and many other things. Good, so pretty much if I go to localhost without HTTPS on 500, this is the administration of the system. So since the administration is working with all the other services, we can easily check whether everything is working correctly. In the identity microservice, in the data, there is identity data seeder class. Here we can find the admin email, and in the app settings we can find the admin password. So I'm going to use that. Well, we can see that the administration is working. It shows that we have 3 carrots. If I click on dealers, I can see that there is a single dealer here. So apparently, I believe everything works correctly because I can log in into the administration account. I can take a look at the statistics and I can hit the dealer's endpoint. So everything should work correctly. And finally, I can check that on localhost 5500 slash health checks, I can check whether all parts of the system are up and running. And I can see that identity, dealer statistics, notifications, and admin, everything is healthy. Their SQL Server instances are up and running, and the RabbitMQ instance is also connectable. Good. Good. So the microservices should be up and running and everything looks great. Everything looks completely fine. What I want to do now is I want to move these microservices into a Docker Compose system so that I can easily start them with a single command and I can easily see whether they work together correctly in their specific containers. Because if I want to deploy and use these microservices in a production environment, it will be a good idea to move them to Docker. Currently, they don't have any Docker support. Everything runs through Visual Studio, as we saw earlier, and every microservice is just a separate console app. We can easily find the ports of the different services by going to Properties, Launch Settings, and we can see that these apps are accessible on specific ports. Each microservice has its own port, like this. Good. So next thing is to actually create a Docker Compose file. So I'm going to just create a docker compose.yaml file, and you can easily see that I've added the final solution here. We're going to reuse and copy some of the information here, because it will take quite a lot of time to type all of these things by hand. So first things first, I would like to start the other solution we're going to build step by step by specifying the version of the Docker Compose file. You can use the latest version, it doesn't matter. And by specifying the services which I want to include. Each different service means a separate container which I want to run something specifically in it. Good. So what we need is we can actually go to the diagram and start from the less dependent things. The less dependent things are the databases and the event bus. So the first thing we want to do here is we need to create a service for the database. To create the service for the database, we need to understand how to run SQL Server in Docker. Running SQL Server in Docker requires the following thing. We need to say, I want to use this image, SQL Server 2019 latest. I want to expose this port here. I want to have two environment variables. This is coming from the SQL Server documentation. So the first environment variable is I'm accepting the end user license, and the second environment variable is setting the administrator password. All of these can be easily found if you go to Docker SQL Server. If we open the official Microsoft SQL Server image, we can read how to run it. So it's not something that is super difficult to find out. So this command will run Microsoft SQL Server. What we need at first is we need to create a service, and we don't have anything specific here. We can create a data. This will be the service to serve our data. Then we need to specify some things. We need to specify everything that is part of the Docker command. We need to specify the image, the port, and the environment variables. So adding these things is quite straightforward. We need to say, hey, I want to have the data service coming from the image, which is the official SQL Server image. I would like to name the container SQL Server. This is important. This is important because our app connects to SQL Server currently through localhost. We can find the connection strings in the app setting files. So we connect through localhost, which is okay, but in a Docker environment in which we run different services in different containers, we need to specify the container name the way it will be discoverable in the network itself. So this name here, SQL Server, is important because this is how we're going to connect to the SQL Server later with the connection string. Everything else is pretty much straightforward. We just tell Docker Compose to run the image, which is here. We tell that we have port 1433 mapped to port 1433, and we specify environment variables exactly like the documentation tells us to do. So we pretty much accept the end user license and provide some password here. Good. The next thing we need to do is we need to specify a volume. The volume is, I believe it will run completely okay if we decide to say to validate and run this Docker Compose file, we need to go to the console in which we have the Docker Compose file, and we just need to type docker-compose up. Docker Compose up will start all my services which are specified in the docker compose.yaml file. So it will start the data service which is specifically written here. So I'm just going to run it to check whether the SQL Server instance will run, and we can see that we have the SQL Server running, and it will fire in a minute. If we don't want to see all these logs, we can run docker-compose up-d. I'm going to use it in a minute because it's everything is too verbose and it has a lot of details. So what is important here? The important thing here is that SQL Server will not store the data automatically, because usually the containers by design don't store anything. If you restart the container, all data is lost. And since this is a database, we cannot afford to lose any data. So every time I stop SQL Server, I'm going to lose the database inside, which is not very convenient. SQL Server stores the data of stores its data to this path -var -opt -mssql. So if we map this path to an external volume in Docker, we're going to store everything in our service. So what we need to do is we need to define a volume. The volume is defined pretty straightforward if we don't have any specific settings. If we just want the default volume, mapping and the default volume functionality, we just say I want to have a volume which I want to be named SQL data, and that's pretty much it. The next time I create and I run Docker Compose up, this volume will be created by Docker automatically. What is left is I need to specify the volume on the SQL Server itself. So what I need to do is I need to specify first, I need to tell Docker to create the volume with the name SQL data, and then I need to specify in the SQL Server service, I need to say I want to map volumes, and I want to map this folder here, which comes from the documentation, we saw it. I want to map it to the volume which is defined below. Pretty much I'm saying this. And from now on, if I run the data and if I create any databases in SQL Server, they will persist. I'm not going to show that because it's currently it's not that important, and everyone familiar with Docker will know that this is pretty much true. I'm just saying how you can do it through Docker Compose here. So defining a volume. If you want, you can specify some configuration here, but normally it's not required. So defining a volume and then mapping a folder for that specific volume. Good. So for now, our data service is complete. This will contain our data service, our database. Next, the next thing which doesn't have any dependents is the event bus. And for the event bus, I'm using RabbitMQ. So for RabbitMQ, what we need to do is we need to take a look how to create a RabbitMQ instance. So the RabbitMQ instance runs this image, maps this port here 5672, specifies host name and name, and puts two environment variables which are default user and default password, and these are important. Also the host name is important because we want to be able to connect through this host name, and all the other containers are going to use RabbitMQ, the host name we specify here. Good. So to run everything here, we need to specify another service here, and we can create it messages. We need to create another service, messages. This messages service pretty much has everything the same as SQL Server, just with different settings. So I'm going to copy everything here, and I'm going to explain it. First, we need to use the image. RabbitMQ management is the image here. Then what we want to do is we want to specify the container name, again RabbitMQ. It's what we like to do, but it's a good idea to be the same as the host name. We specify the host name here, the same way we specify the host name in the PowerShell command. This is important for the connection string of RabbitMQ, and this is important for other containers to connect to the message broker. And for the environment variables, we specify RabbitMQ default user, this one, and RabbitMQ default password, this one. Good. What is important here is that RabbitMQ also needs volume, because RabbitMQ is a message broker. It receives messages and makes sure that the recipient on the other side gets them. So if for some reason RabbitMQ fails and it needs to restart, it has a mechanism to store these messages on the hard drive. So if for some reason RabbitMQ fails, we need to have its hard drive mapped to a volume. So we need to store the RabbitMQ data into a volume, because if we have any failure of the event bus, some messages may be lost, which is apparently not a thing we want in our microservice application. Good. So according to RabbitMQ's documentation, we need to map var lib RabbitMQ mnesia. This is the folder, and the exercise is pretty much the same. We need to define another volume, RabbitMQ, and we need to specify the specific volume here. RabbitMQ var lib RabbitMQ mnesia. This path comes from the documentation. But now, if I run the RabbitMQ service, it will store its data on a volume, which is the important part here, because we don't want to lose any messages. So let's go and let's try that again. Docker compose up -d, like this. This is the command I'm going to use, which pretty much means start the services. Well, we have some problem here. The container name RabbitMQ is already used. Yeah, because I already started a RabbitMQ instance and it has the same name. So what we can do is docker ps prune. Docker ps first. Let me check it. RabbitMQ management, RabbitMQ. So what I need to do is I need to say docker rm RabbitMQ. You cannot remove a running container. Docker stop RabbitMQ. Docker rm RabbitMQ. Docker ps. So I guess if I run docker compose down, this will kill all the services which are run from the docker compose, and then I can run docker compose up -d. we can see that this creates RabbitMQ, creates SQL Server, and doesn't show me any logs. So if I want to show specific logs for a specific service, I can say docker compose logs RabbitMQ. Show me the logs of RabbitMQ. No such service RabbitMQ, yeah, because actually the name of the service is messages. Yeah, my bad. And we can see that RabbitMQ is up and running. Good. So docker compose down. Good. The next part of the system is the different API services. So the next thing we need to create is identity service, dealer service, and statistics service. They are similar. So let's take a look on how to create them. First, each of these services needs a Docker file. We need to specify how to build the Docker image for the specific code solution. Fortunately for us, Visual Studio has support for Docker, which just and we just need to tell add Docker support here, and it will create a Docker file for us. So I've already created that. And this is automatically generated Docker file, so we don't need to do anything here. I've already created that to save some time from the video, but I just added Docker support on each of these services. Good, so let's go and take a look at how to run the identity service. To run the identity service in Docker Compose service, we just need to transfer all these settings, application settings, as environment variables because we want to have easier control over them. What is important here? It's important that we have these application settings common for all of the services. We can take a look here in the dealer service, and we can see that the application settings are the same. And on the statistics, we can see that application settings are the same. These application settings are pretty much the same because they contain the JWT token secret. So the authentication and authorization, in order to work correctly, we need to have the same secret. And if we have the same secret, then the authentication will work correctly through all of these microservices. So these application settings are pretty much the same. So what we can do here is we can add a common file, common environment file, here it is, containing these settings for us. So these will be the common application settings which are used by the dealers, by the identity, admin too, I believe. Yep, here it is. So what we can do here is we can create a common environment file and notice how to convert an app settings to environment variable. You just need to use 2 underscores for each nested object in the JSON structure. So if you want to convert service endpoints identity to an environment variable, you just need to create service endpoint underscore underscore identity equals to the environment variable here. You will see that in a minute multiple times. So in order to work with common environment variables, we can create a common.env file and we can list all the environment variables here. As you can see, I've already transferred them. So the application settings underscore underscore secret equals to the actual secret, and application settings underscore underscore seed initial data equals true. Seed initial data is easier for testing purposes because already seeds the administrator, already seeds a dealer, and so on. Good. So let's go to the identity service and let's start moving it. What we need first is identity. Then again, we need to specify container name. We need to specify how to build the image, because this time the image is not a third-party image already on Docker Hub. We need to build it locally. We need to build it from our source code, from our Docker file, which was auto-generated by Visual Studio. So the identity, pretty much everything is straightforward for the first couple of settings. So container name, I'm saying identity. This is important if I want to have another container accessing identity through the network. Then I have an image. The image is whatever I prefer. Usually you should prefix it with your Docker Hub username. So this is why it's eval_current system identity service some version. Then I specified the build. Since it's not a third-party image, I need to specify how to find the Docker file. And I'm saying go to the server folder and use the Docker file, which is in current_system.identity Docker file. And you can see that on server folder, current_system.identity Docker file, there it is. Good. I say run the port on 5001. I copy the port from identity properties launch settings. Here they are. I'm just using the HTTP port because the HTTPS needs additional configuration on Docker, and it's not the focus for our lesson. By default in Docker, .NET Core runs on port 80. So we just need to map this service to a specific port. And finally, you can see that I'm specifying a specific environment file, server current_system common environment file. This is the environment file here. Here it is. I can run the app as it is, but I need to transfer some other specific settings for the identity service. These settings are not common, and they are only for the identity service. These are the admin password and the connection string for the identity database. So in order to do that, I just need to say environment and provide the settings. But there is something specific here which is very important. First, let's check the identity settings __admin password. This should be pretty straightforward. Identity settings __admin password, pretty straightforward. But the connection string to the database is different. Here the connection string is calling the localhost SQL Server, and it's using integrated security, which cannot be used in a Docker environment. So first we need to change the localhost server, and then we need to provide an actual username and password instead of the integrated security options here. So how to do that? It's very easy. The name of the SQL Server instance is just SQL Server, like this. So instead of localhost, we need to call SQL Server. Now, if you take a look at the connection strings __ default connection, which is the same as this connection here, you can see that I'm not using localhost, I'm using SQL Server, the name of the database container. Then the database is the same. And then I'm not using integrated security. I'm using user ID, which is the default system administrator. And I'm using a password, which is the password I provided here. So the passwords must match if we want our identity service to connect successfully to the data service. So this is the important part here. We need to change how we communicate with the database and with the other services in general. We need to change the localhost part, and we need to specify the password, the specific password. Good. Some other settings we need to do are we need to specify restart on failure if we want to have automatic restart of the service. And what we can also do is, since ASP.NET Core uses keys to generate uh, some data protection values. You can read about ASP.NET Core data protection. If you run the service as is with these settings, it will show an error that the data protection keys are not part of a volume and will be deleted, which may bring invalid application state in terms of session, cookies, and so on. Just read about ASP.NET Core data protection. ASP.NET Core data protection keys in Docker, and you will understand what I'm talking about. It's too ASP.NET Core specific. This is why I don't want to include it here in the lesson, but consider it that you need to put the data protection keys on a volume. Otherwise, if the Docker container restarts, you will lose the session state, which means that you will start showing receiving errors on anti-forgery tokens, for example, which is a bad experience. So it's a good idea to put the data protection keys in a volume. How to do that? Well, we can specify the volume the same way we specified it in the data service, but instead of creating a named volume, we can just specify a folder, and when we run the app, you will see that it will create the folder here locally. According to the documentation, every ASP.NET Core app which uses data protection key, and if you use basic features as session or anti-forgery tokens, you will use data protection keys. What you need to do is you need to map this folder /root/.asp.net/data protection keys. You need to map that to a volume, and that's pretty much it. So if you run your service without this setting, you will receive a warning, and if you research the warning on Google, you will see that the fix is very simple. Just create this volume. Okay, and you can see that for each service I'm going to use a separate folder because I don't want these keys to be mixed. I want every single service to have a separate key. Good. Then what I can do is, what I need to do actually is to make it possible for the identity service to call the database. Currently, in the Docker environment, these two are not familiar with each other. They cannot connect with each other, and we need to map them to a network. So what we need to do is we need to define a network the same way we created a volume. What we need to do is we just need to say, I want to create a network which will be named whatever I like. Car rental system network is good enough. So let's go and create the network. And now what I can do is I can specify which networks each service is part of. So I want to say that the database is part of the car rental system network. This is important because all containers in the same network are visible to each other. So if I want to have the identity service, if I want the identity service to be able to connect to the data service, I need to make them part of the same network. So you can control the container visibility by using a network. I'm just going to add the network to the messages too, because later when we want to connect to messages, we need to be part of the same network with the message bus. And finally, the identity service also needs to be part of the network so that all of these containers will be visible with each other. Good. What we can finally do is we can add this depends on data setting, which just helps Docker Compose how to run the services. This pretty much says First run the data service, and when the data container is ready, then run the identity service. This will reduce the errors because initially when the identity service tries to run, it will tries initially to connect to the database, and it will fail because most probably the data service will not be up and running. It won't be ready. For this reason, it's a good idea to just specify depends on data to make sure that the identity service runs after the data. Good, let's test this. Let's run docker compose up -d and see what happens. So we have creating SQL Server, creating RabbitMQ, creating identity. Oh, wait a minute. Let's run that down. And let's first run docker compose build, because first we need to build the image. It was working only because I've already built the image before the lesson. But if you're doing this for the first time, you just need to run docker-compose build, and this will build all third-party images, all non-third-party images. Like you see here, data uses an image skipping, messages uses an image skipping, and as we can see, it built the car rental system identity service image for us. Good, now let's run that again, and we can see that everything is running. What we can do is we can go to docker compose logs identity and see what it's showing. Currently it's not showing anything. Which should mean that there are no errors for the identity service, and we may check whether the identity service is up and running by calling register. So if we go to localhost identity -register, this should return HTTP error 405. HTTP 405 is method not allowed. It means that our service is up and running, but I'm trying to make a GET request for a post action. So we are receiving the correct status code here. I just don't want to open Postman and create a post request on the register, because we're going to test that a little bit later when we add the different other services, but we can see that this service is apparently running, and if the logs are showing pretty much nothing, that means that we have everything running smooth. We don't have any errors and we don't have any warnings in this service. So this looks completely fine. Now we need to do the same for the dealers service and for the statistics service. We can take a look at the app settings, and we can see that we have two connection strings. The one is for the dealers database, and the other one is for some Chrome jobs which are done on the same date, which are done on this service. So apparently we have two different databases, so we need to create two different connection strings. We also have some message queue settings, and here is the tricky part. The host here is localhost. We need to make sure that we change localhost to the corresponding messages container name and host name. So we need to change localhost to RabbitMQ. That's the important part here. So good. Let's go to the final solution, and I'm just going to copy everything from the dealers because there is nothing new. we just need to specify more connection strings and more data. Here is the dealers. And now let's take a look at it. We have the container's name, dealers. The image is the same but with dealers. We just want to build the image from car rental system dealers Docker file. The port is different than the previous service. We have a common environment file name because we have the common settings here, and then we have connection strings default connection and connection strings cron jobs connection mapped to the specific database. It's important to understand that we don't connect to local host here and we don't use integrated security. We connect to SQL Server because that's the name of the data service image of the data service container, sorry. And we use the specific user ID and password. For RabbitMQ, we create the same settings, but instead of using localhost, we need to connect to the messages. Let's run it with localhost. Let's see what will happen. I'm going to specify, but first let's create the statistics too, because they are pretty much the same. Nothing interesting there. Just to finish all settings of the dealers, we have again restart on failure, and we have a volume for the data protection keys in the dealers. If we go here, we can see that the identity already created their keys. Here they are. The network is the same because we want to connect to the other services, and we say we depend on data and messages. So don't run the dealer service before the database is ready and before the event bus is ready too. Good. Let's make sure that the statistics are specified too. You can see that there is no difference here. You can see that the statistics service is exactly the same with almost exactly the same settings, just the names of the databases are different. Statistics database and statistics cron jobs database. The statistics image, the container name, everything is the same except the port and the names statistics. Good. So let's go here and say docker compose build. We can see that the identity service was built quite fast because it was already built and it don't need to rebuild it. The dealer service is now created, and now we're going to receive the statistics service. A second. Done. Everything is good. So let's run docker compose up-d. We can see that SQL Service, RabbitMQ, and Identity were already running. This is why it's showing up to date. And dealers and statistics are currently running. Let's check Docker Compose logs dealers. We can see that there is some warning. No XML encryptor configured, maybe persistent in storage. This is fine. Docker Compose logs statistics, we can see the same warning. This pretty much means that the keys will be stored in a volume. Otherwise, if we didn't have a volume, we would have two warnings here, not a one. But we don't specify any SSL certificate or any encryption, so these keys are stored in a pretty much human readable way. These keys are not encrypted, so we have a warning. The key below is in an encrypted form. Of course, this can be easily solved if we follow the documentation of ASP.NET and encrypt the keys by using a certificate, but it's out of the scope of this lesson, so we don't care about this warning. Good, and we don't receive any other error messages, so we assume that the RabbitMQ connection was successful. We can check it by say give me the messages logs, and we can see that we have accepting connection. Here it is. Accepting another connection. So one of these is the dealer service and the other is the statistics service. They both try to connect to the RabbitMQ instance and they are both successful. You can see that there is even the name car rental system.dealers here. User RabbitMQ authenticated and granted access, great, and car rental system statistics. So apparently we're able to connect to the RabbitMQ instance. And if I say docker compose, I'm not going to bring them down because it would take more time to restart them. What I wanted to do is I wanted to say localhost here. For example, if I copy paste the statistics settings from here without thinking too much, or if I'm distracted or whatever, if I try to use localhost and if I say, well, let's run docker compose up, this should recreate statistics, and statistics should now show an error. Statistics. No error for now. Let's check docker compose logs messages. Car rental system statistics, again it was connected for some reason, but it's interesting whether it uses the correct environment variable here. So I paused the video to research about the localhost here, and apparently after a specific Docker version, I'm not sure which one exactly, if two containers are sharing the same network, they can call localhost, and the containers with the services will be still accessible. But in my opinion, it's a good idea to still use the names instead of localhost, because locally you may have a single network, but on a production environment, maybe your Docker Compose will have separate networks, and maybe you have trouble identifying different containers in the networks. So my advice here is to always use the name of the container instead of localhost to make sure that you don't run into any issue. And also, if you deploy, for example, on a public cloud, you're not sure which Docker engine may be running there. So just to be sure, use the name directly. Good, so we created the identity, the dealers, and the statistics. What is next is we need to, currently we have pretty much these things here. Everything should be up and running. Next are notifications and the two clients. So let's create the notifications. Let's go here and take a look at what happens to notifications. Notifications, they don't have any database. They have the common application settings and the message queue settings and some course settings. So we need to provide the origin here of the client apps. Currently, we are going to use localhost because everything runs on localhost, so we are going to leave localhost here. But otherwise, if, for example, the domain was coded up .today, we should provide it here. So in our production environment, we should provide the full domain here, and most probably it will be HTTPS. But for localhost, we are going to use localhost. So that's pretty much it for the notification service. If we go here and get it, we're going to take a look at all the settings. So a lot of things are the same: container name notifications, image notifications. We built this from the notification Docker file. Ports, we map the 5004 port. We have the common environment file, and we just transfer these environment variables here. Once again, we don't want to use localhost for RabbitMQ because we want to access the container in a safer way. And by here, the allowed origins, we're going to leave it localhost because our clients and our browser comes from localhost. On a production environment, we should change this to our domain. Good. Again, we start on failure, the volume for the data protection keys, we map the same network, and we say that this service depends on the messages. Good. Let's take a look at the admin app settings. The admin uses service endpoints because the admin calls the other services to get the data. Take a look at the diagram. Here it is. The admin client calls through HTTP all the other services to fetch and make CRUD operations over the data. So we have identity, dealers, and statistics here through localhost. Of course, in our Docker Compose file, we need to change these to their names, but pretty much everything else should be the same. The common environment file, and we need to provide service endpoints app settings. So let's go here, and I'm going to leave the client for now. It will be the final thing we're going to run. Docker Compose, like this. So we have the admin, we can see the container name, the image is the same, we built from the admin Docker file, we specify the port, we use the common environment variables because the admin needs authentication, and we provide the service endpoints underscore identity. We can see that we call identity directly. Service endpoint dealers, we call dealers. That's because we just want to call the dealers container, we just want to call the statistics container, and so on. So using this is good enough. Good. We have the data protection volumes and we have the network. Okay, next is the watchdog, and finally we need to specify the client. So the watchdog has nothing interesting. The watchdog is a pretty straightforward ASP.NET Core app. It just needs these settings: health checks UI, health checks, and an array of health checks to validate. We can see that it validates identity, dealer, statistics, notifications, and admin. And in order to convert that array into environment variables, we just need to use the indexes. Let's take a look how it is. Watchdog. So the watchdog, we can see that the container name, the image, the build, everything the same, the specific port, and we just provide the environment variables. We can see health checks UI, health checks, 0 name, 0 URI, means that we map this object here. then one name, one URI maps this object here, and so on. So we specify co-identity health, co-viewers health, co-statistics health, and so on. These are the transferred URLs, because like we said, we don't want to use localhost because we want to be sure that these settings will run correctly in other networking environments and not only on localhost. Restart on failure networks, current system network, and we say that the health check depends on everything else because we want to make sure that everything else is up and running before the health checks. So finally, we need to provide the client. The client is an Angular app, so its Docker file is a little bit different. Its Docker file is building an Angular app and running an Nginx server to serve the Angular HTML, CSS, and JavaScript files. And this is exported on port 80. So this is a straightforward Docker file which just runs npm install, installs Angular, sets an argument configuration production on configuration development, it depends on the build, and then uses Nginx to serve all these files with a specific Nginx configuration. This is pretty much a tutorial from the internet. If we decide to say create a Docker file for Angular app, you will find a similar Docker file. Good, and the client is quite straightforward. Let's add it too. The client has container name client, the image is user client 0.1. We have the build context client, Docker file, and something else, which is arguments, configuration, development. The whole idea here is that because we are running this Docker compose file on localhost, we want to specify the configuration build of the Angular app to not be in production. Because if we run production builds, they will minify the JavaScript, minify the CSS, and it will be more difficult for us to debug anything. We extract port 80, and we say that we depend on everything that is here on the diagram. And that's pretty much it. Now let's go and run it and see whether everything is working correctly. Docker compose up -d. Well, I forgot to run docker compose build, so let's run that first. This will build all updated images, for example, notifications. Then the admin. We can see that the Angular build was fast because it was already built and nothing has changed. Good, great. And now let's run docker compose up -d. Everything is up to date. It was recreated. I don't see the client. Let's check it out. If I go to localhost 500, I should see the viewers. Great, the administration. If I go to 5500 health checks, everything works correctly. And let's check the client. The client is also online. It calls the service. We can see that we have 3 carats. We have multiple carats here. Everything works correctly. We can go and try to log in with the user because there is a user, default seeded user in data, identity data seeder, and this is the username. No, this is the admin actually. This is the username, cool cars, and the password is this. So we're now logged in. We can take a look at our cars, we can hide them, we can create a car ad and so on. And if we go to the console, we can see connection started, which means that we successfully connected to the notification service. So the notification service should be running too. Like we see here, a WebSocket connected to localhost 5004. To validate that, we can easily go and say and we can add this car, for example, copy image address, BMW model M8, for example, luxury, image per day, price per day, climate control, number of seats, transmission type, and we create, and you can see that we have a notification here. So apparently the notification service is working and everything is working fine. Yep, we added a car and the statistics updated, which means that the event bus is working correctly. It's because when we add a car, what happens is that the user client sends the data to the dealers. The dealers store the car out here and then tell the event bus that we have a new car added, which fires an event here in the notifications, which goes to the user client, and fires an event here to the statistics service to update the statistics. And we can see that the statistics were updated and we received a notification, which means that the whole system is working correctly. And now we have updated the whole microservices app to be using Docker Compose. So this is a practical example of a fully working microservices app ported to Docker Compose, and it's way more convenient to use Docker Compose because you can run easier services, you can analyze their logs, you can stop them, restart them, rebuild them, and you can see how they are going to work with each other in the production environment. What is important here, it's important to understand how to transfer all the environment variables, to understand how to use third-party containers, how to match this command here to Docker Compose file here, to understand that the connection shouldn't be done through localhost, even though it may work on specific Docker versions. Back in the day when I first started with Docker, localhost was not working, but apparently they decided to integrate it to make communication between services easier. Nevertheless, it's a good feature, but I prefer to use the actual container names because in your production environment you may have more networks or you may have different configuration, and it's a good idea to have specific container names because it will be easier for you to connect to the other services. So the most important things are to match the same ports and to match the environment variables. These volumes here are ASP.NET Core specific. You can read about data protection keys in the documentation, and these two volumes are coming from the documentation of RabbitMQ and SQL Server. And that's pretty much the key thing, to know how to transfer the environment variables. That's the most important part, so that every service can connect to the other service, and so that the connection strings are okay. Well, good, that was it. I understand that there may be some missing pieces of knowledge here and there depending on your level. So if you have any questions, for example on Docker, or for example on ASP.NET Core microservices, or anything which was not clearly explained in this tutorial, you can shoot me a message anytime you want. Because the specifics of these lessons and the main focus here was making sure that the microservices app, which works perfectly fine in Visual Studio, can be easily ported to Docker Compose. That's the most important part here. So yeah, I believe that I covered a lot. We transferred everything, and once again, if you have any questions, let me know. Thank you for now, and bye.